today's stream will be mainly on Google Kickstart. So just recently, like last Sunday, I took part in Kickstart. So that was round D, and it was this one. The main problems, there were four of them. Arithmetic square is basically like a Sudoku. Okay, not a Sudoku, but it's more like you have a square, and then in the middle there's a number missing, and then you need to fill up the number such that you form an arithmetic sequence. So you need to maximize the number of arithmetic sequences. And the key to solving this is that when you do the middle number, you actually don't like loop from the start value to the end value because they gave a very large value, 10 to the power of 9. What you do instead is you take the first value and the next value, and then you calculate what should be in the middle. Then you form a dictionary or hash table to pick the number that gives the most number of arithmetic sequences in that square. So yeah, this one wasn't too difficult. Oh, is my computer lagging? Yeah, so I managed to do a partial solve for the second and third question. The last question, actually, I thought I solved it, but I didn't. But yeah, so that's something that I will go and work on to like practice how to solve this few problems. Oops, wrong page. Yeah, it was quite it's quite unique because the second and third problem for round D was mainly to do with like using dictionaries or hash tables to store the sequences, which would otherwise be too long to store in an array because it's like 10 to the power of 12, I think. Yeah, the range. So yeah, today we'll be doing some past problems. So last time I did round H, now let's do round G. Okay, so Kickstarter round G. Let's create a new folder. Kickstarter G. Okay, let me just do some technical checks for my stream before I start this. Yeah, yesterday I wanted to stream actually, but there were some real life issues that cropped up, and that's why I didn't manage to stream. But it's alright. Yeah, we'll try to maintain a more regular stream schedule. Okay, so this is Kickstarter round G. I'll try to solve like maybe the first two questions if possible in an hour. So let's just copy and paste whatever I type here. So this problem is called Kickstart. How apt. Alright. So let's open this with Visual Studio Code, one of my favorite editors. I realized in the last Kickstart round D, I realized that actually I haven't been having the latest C++ version. I couldn't do a for range loop, so I had to do the traditional for loop. Yeah, so I should go and get myself installed the latest one. But I mean, even without the for each loop, I think it's still fine. Okay, Kesnia is very fond of reading, kicks off each day by reading a fragment from her favorite book before starting the rest of her morning routine. A fragment is a substring of text. Kesnia is somewhat superstitious and believes her day will be lucky if the fragment starts with the string kick, then goes on for with zero or more characters and ends with the string start. Oh, this is like a this one looks like a regex problem. Maybe I should use Ruby. Two fragments are considered different if they start or end at different positions in text. So kick start. Kick start. Count the number of different lucky fragments that Kesner can read. Oh, this is definitely not a regex problem then, because there are many possible lucky fragments. Two fragments are considered to be different if they start or end. Okay, so this is kick start. Kick start. So kick start here, and then we can have kick and a start here. So basically, we just count from each position kick, like how many starts are there at the back. So we start with this kick, and how many starts are there at the back of it. So let's say we have an array of kicks where there's like four different positions, and from each of these positions you have to find out how many starts are there after that position. Yeah, so I guess the first thing I'll do is to just read in the input first. The usual stuff for the kickstart problem is to take in the input. So this really feels like a clash of code, this first problem. Different if they start or end at different positions of the text. So I guess you need to key in the, the string. Actually, I could just put s equals to get line, c get line c plus plus. Yeah, just get line s. Let's just see whether whether input output is handled correctly. Just to check. 3. No matching function called to get line. Oh, must be c in s. Oh, when I type enter, it assumed that this was the line already. So maybe I should just do this. Yeah, I don't use get line because it will take in the first input also. Okay, so this settled it already. So now I need to find out where are all the kicks in the position of the array. Okay, so maybe what I'll do is I'll just count from the back, and then I just take note of the cumulative count of each position of the array from the back. I mean, it could also be from the front. I mean, I can count from the front as well. So there'll be 1 kick, 2 kick, 3 kick, 4 kick. Let's just count from the front. I mean, I don't know how many positions are there in the array. Vector. This one will be an int. S dot size. Or S dot length. Yeah. Maybe I initialize all them to 0 and then start. For int I equals 0, I smaller than s dot size I plus plus. Okay. I minus, okay, so kick is 5 characters, right? So minus 5. So if let's say I have, so I need to have a cumulative count here. Can be integer because 10 to the power 5. Kick count is 0, start count is 0. Okay. If I smaller than s dot size, okay. So this is to find out where the kicks are. And then I'll also do another one. Find out where the starts are. Okay, so let's try to find a substring. C++ method. I never get a substring. I mean, in Python this would be quite easy. String dot substring, and then the first number is the position and the length. Great. So string dot substring I, and the length is 5. And if this is kick, this is actually start. So actually this is where the starts are and this is where the kicks are. Here we do the same thing also. Start count. Okay, so that's all for this. So maybe what I'll do is at the end of it, then update the kick. And I'm not sure whether there's an easier way to do this, but this is the only way that I can think of most easily. So maybe kick I equals to kick count. Yeah, so basically this will keep track of where all the kicks and the starts are. So maybe what we'll do is uh, maybe we'll just print out the position, kick and position, kick I. It's just to do error checking. Start I. And then we do it and okay. Oh, okay. It's actually S. Yeah, it's not string. Let's try doing this again. Right, let's try doing this again. Yeah, no, I was just checking whether my Twitch was on. Okay, so C3, kickstart, kickstart. Okay, so at the fourth index, it will be kick, yes, correct. And the zero index kick is up there. And start will be at 0, 1, 2, 3, 4. We will have start. Oh, I'm not getting the kick is correct, but my last start is not there. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this 9 and this 9, 18. So I should have 17. And then this position here should be 16, 15, 14, 13. It should be at the 13th position here. I should be getting a hit. S dot size minus 5 is, so S dot size will be 18 minus 5 is 13. Yeah, it could mean that this should be an equal rather than a smaller than. Yeah, because if at the 13th position I cannot scan for the start, I should be smaller equals to, because at this position this is S and there's still four more positions. Okay, so let's just try run this code again. Okay, start. Okay, I forgot to check whether it's all capital, but you see there's an issue again that it didn't sense the starts. Okay, how about start kick? Yeah, it didn't sense the kick as well. How about this kick start K? Now it senses it. Yeah, one way to do it will just be to just increment the length by one of the string by one, but I'm just trying to figure out why. I mean, even when I do smaller equals to, it doesn't work, because you see 18 minus 5 is 13, so at the 13 mark they should already do this. Oh, maybe I didn't save it, so let's try again. Kickstart. Oh, see, yeah, I didn't save it. Okay, so I suppose it's all going to be capital letters, uppercase letters. So kick kick start, kick start. Okay, so what I'll do is, because kick count, as long as the kick count goes 1, the start count doesn't matter. So at the kick count goes one, we take note of this count here. So this count is one. So we know the start n 3. So this will be 3 minus 1. So that, yeah, so maybe a good way to do this is basically, so basically we just need to, oh, actually I did it too complicated already. We just need to start from the end of the string, and then we basically uh, just make sure that we start from the end of the string, and then we just make sure that we take note of where the starts are. And then the moment once we encounter a kick, we just add to the array. So actually I didn't need all this. So actually all we need to do is just have a total. Yeah, so and then we need all the start, because whenever we receive a kick, then we're just going to add the start count to the total. So when we receive a kick, okay, we're just going to count. So total plus equals to start count. Yes, and then once we see a start count. So over here, what we do is we look from size -1, and then we go to 0. So we start from the back of the string. Okay, because the main thing that affects us is start. So start will be the count. So like let's say the kick over here, there's two starts already. So this is 2, and this kick has only one start, so it's 2 plus 1. So at the end of there, I can just see out total. Okay, I think this should work. Okay, I'm not gonna check. I think this is probably good enough. I don't even need this vector. Okay, so it's just basically I converted a vector update into like just updating one variable. Okay, let's just try. Okay, let's copy and paste this. 305. Okay, it looks good. I think this code is correct already. Oh gosh, what did I do? Oh, I think I deleted it. Yeah. So yeah, that took about 10 to 15 minutes. I think that's not too bad. Let's just see whether it works. Okay, so this was my code just now. Select C++, submit. Let me see whether this code works in the Kickstart. Oh, it's only 4.7 points, so little points for this problem. Yeah. Someday I'll need to get better and attempt the problem 3 and problem 4 of Kickstart, because those are the problems that will differentiate me. You see, in the previous round D, I did like I did 3 problems, and then that got me about 2,000 place. Yeah, so first problem solved. Second problem is one. Yeah, I mean the time here is a little long because I started half an hour late. I was busy. Yeah. So yeah, I thought I could, solve the second problem, but it was a little too hard for me. After I looked at the solution, it still looks a bit tough. So I need some time to go and digest and analyze how to solve this. Same thing for final exams. This primes and queries surprisingly was difficult. I thought it was easy. I mean, I got the test case one correct on my laptop, but then it didn't work in time. There's a time limit error. I mean, it ran out of time. So I'll try to see that I can solve all this. But meanwhile, let's just try to solve a past year question to build up some confidence. Wow, so many people solve this. Okay, maximum coins. Okay, so we are done with Kickstart. We can move to maximum coins. I don't know how these people do it so fast. Like they solved it in like 5 minutes, I think, for the first question, the fastest person. So that's really amazing. If you can solve that question in 5 minutes, it means that you have a lot of uh, you are very well versed in this kind of algorithms that you can solve it so fast. Practice makes perfect, so we just gotta keep practicing. All right, just keep practicing. Okay, maximum coins. Mike has a square matrix with n rows and columns. Cell ij denotes the cell present at row I and column j. Cell 1 1 is top left of the matrix. Each cell has some amount of coins. and Mike can only collect them if he visits that cell. Cij represents number of points in cell with row I and column J. Cell, he can decide to go to cell I plus 1, J plus 1, or I minus 1, J minus 1. So it's diagonally. You can choose to start the journey from any cell and choose to stop at any point. So he can go to the diagonal, either the forward diagonal or the backward diagonal. Or 1, 1, 1, 2, 2, 3, 3, 7, 14. Does he always start at 1, 1? Or he can start at any cell and stop at any point. So basically it's the entire diagonal. And it's always positive, right? These values of the cell. Yeah, at first I thought it's a graph problem, but it cannot be because it's problem 2. So it definitely isn't. So this one is just the diagonal like that. 2, 3. Yeah, it's this diagonal here. So basically it is a case of counting the diagonals. Yeah. So it's like that, like that, like that, like that. Yeah. So I mean, there's not many diagonals to count here. But one thing for sure is that there'll be this amount plus this amount. I think it's just a simple for loop for this. And all of them are positive, so there's no way that your negative can influence. Yeah, it's a pretty simple problem. All right, so first digit is first digit is n. Okay, let's. Seems that the problems in Kickstart in the past were much easier than Kickstart in 2021. I don't know what changed in Google that made make the difficulty harder. Next, n line contains n integers each. J integer in the ith line represents the number of coins. Okay, then coins is n by n, right? So in this case, n maximum is 10 to the power of 3. So I can just put 1001. I was play safe by putting one more. So okay, so we take in the n for the row for j smaller n j plus plus. Okay, we see in this points ij. Okay, so then after we want to do is count the diagonals. Okay, so maybe we do the top diagonals first. So the start can be either 0, 1, 1, 0. Yeah, so my start I can be here, can be here, can be here, can be here. I'm just thinking how to start this matrix. So we can just have a start point where usually my I is 0, and then I loop all the j's, and then my j is 0, and then I loop all the i's. Yeah. So count the fix row carry column. So what I'll do is I have a so start I will be 0, start j will be I. Okay, so we bury the column of the J. Then so we have to count. We have to do this. There's no way to like get any benefits of like recursion or memorization because like when we count the diagonals, these diagonals are all distinct. So when we count this distinct diagonals, you might as well just we can just do a while loop. While start I smaller than zero, smaller than n, and plus, and also we need to check whether so if it's within bounds, then what we do is count plus equals to coin at the and then just need to add. Then we also need a max. Okay, so if so we have max coin equals to max count max coin. Then we just repeat this for the case where we vary the yeah like that. Yeah, I think that's more or less it. And then at the end, we just print out the number. Let's check. Error. Previous definition is here. Did I declare count twice? Oh, okay, they don't allow me to do this like that. So let's put a count here. Oh, it's called coins, not coin. Okay, so we fix the error. Okay, looks like it's good to go. We paste this. Case 1 is 14. 14. Oh, why did I print it out 3 times? Oh. The C out was in the for loop. Okay, yeah, so if I take the C out here, then this should be good. Oops. I wonder so many people solve this problem. It's not difficult. It's just a matter of trying to find the diagonals in the matrix. I love solving partial kickstart problems. They are so much easier. 14. And the case 2 is 9. Okay, looks good. Let's submit this and see whether it works. Okay, so that was about 20 minutes. Not too bad. I mean, if it works, it's not too bad. For problem 2, the problem 2 in the recent Kickstart I took part, round D was way harder. By way harder, I really mean way harder. Yeah. At least this you can put in the matrix. That round 2 problem, you can't put in a matrix or an array because 10 to the power of 12, there's no way you can put 10 to the power of 12 in an array because the memory limit is 1 GB. Oh, wrong answer. Okay, so we have to think why is it wrong. Okay, but the samples failed. Oh, that's weird. It passed for me. I've got to print a new line. Oh well. Oh. New line matters. Let's try submitting again. Yeah. Oh, interesting. solve for this, but it failed. Oh, because this is Cij is up to 10 to the power 7. This can remain in, but the coins will be long long. And the next coin counts will be long long. Because I didn't see the 10 to the power 7 there. That's why as by default, some people just, they just use long long for all their data types, which I think is bad practice. And I think you should only use long long when you need to use long long. If not, we should save memory space by using integers. Of course, if you are using Python, you don't get to control this. But if you use a lower level language like C or C++, you can control your memory size. Great, we solved it. Combination lock. Do we have time for combination lock? Let's try. I mean, it looks fun. Combination lock. We are done with maximum points. Okay. Duplicate this. Combination lock. Should I have double clicked on it? I should have opened it. We just did the code. The combination lock has W wheels, each of which has integers 1 to n. At any moment, each wheel shows a specific value on it. Xi is the initial value on the ith wheel. You can use a single move to change a wheel showing the value x to x plus 1 or x minus 1, wrapping around between 1 and n. For example, if a wheel generally shows the value 1, in one move you can change its value to 2 or n. Okay, so given all wheels integer values, what's the minimum number of moves to get all wheels to show the same value? Oh, it's not difficult, isn't it? It's basically a line. Oh wow, wow, look at that. W and n. W integers. So W is the number of wheels. Okay. And then the ith integer is x. I. Okay, let's take a look. 3, 5. So this is 2, 3, 4. And then there's 3, 5. N is 1 to n. The ith integer is xi. So this is the wheels itself. Okay, let's try to solve this. So what do we do here? We first take in. Let's just use long long because I mean this is quite big. 10 to the power 9. Take in W and n as per what they mentioned in the test case. W and n. Okay, and then over here we take in the three integers. Okay, so I can also do a integer declaration because we know it's 10 to the power 9. So this will be actually it's 10 to the power 5. We can do this. Okay, 5. I like doing this because if I do by zeros, I tend to do it wrongly. So when we have 2, 3, and 4, we just need to see in this to the wheel. Okay, so I don't need the brackets. Then I just need to print out the number. So what could be done is maybe I should just take the average, or I could also try out one by one. But you see, there's 10 to the power of 9, so probably taking the average would be better. Then I take the average, and then I can just shift everything to the average. I mean that might work, but if I were to do by averages, there might be a case where I will not, because there's a wraparound from 1 to n. unless I do both. I wonder if I do a for loop to 10 to the power of 9, will it be good enough? N can be quite huge, right? Yeah, this test at 3, the N can be huge. The issue here is in runtime, it's not the logic of this code. Because, if I were to solve this by doing like, let's just shift all to 0. Oh, actually, if I were to shift all to the same value, and then if I were to move it up or down, then I actually can, but that will be a 10 to the power of 9 runtime. So yeah, let's just try doing this for loop with 10 to the power of 9, see whether it works first. I don't think it works, but you know, so we have a total. So we do this the obvious way first. I mean, I think there's something to do with averages, and maybe I need to do the average by by converting my n to maybe n over 2, and then I shift everything in order to do the average again. Yeah, so I'm not too sure about that. Let's just try doing this first. So total will be plus equals to minimum of, okay. So I think there's an absolute function in C. Yeah, I think just need to use apps, but I don't need to use long apps. I don't need to use math.apps. I can just use apps. So total plus equals to minimum of absolute value of the total plus equals to minimum of absolute value of will I minus I. Yeah, yes, this is the difference between the will and my desired I. Okay, so I need to do another loop. So maybe here we have subtotal. Okay, so we also need to take into account what happens if I went upwards instead. So it's like plus n minus I, because this means that if my wheel to my desired position, if I can turn the backwards direction, then I should do it. Then also we need to do another minimum of, oops, a minimum of this with a minus n to cater for the other direction also, because we don't know what sign this thing is. At wheel I minus I, if let's say wheel is 5 and I is 3, then it's fine. If wheel is 5 and 3 and I is 5, then that's minus 2. Then to get minus 2 plus n, I mean, it can either be plus n or minus n, because it depends whether my wheel I minus I, is it, actually this wheel j minus I. I is the desired number. Okay, so this is my total. Okay, and then it's actually subtotal. So my total will then be the minimum of subtotal and total. Yeah, let's keep doing the minimum. So so since there's 10 to the power of 9 and there's 10 to the power of 5 wheels, this total must be very high. Yeah, 10 to the power of 10 to the power of 14 max. Just wondering, long maximum size. So this, yeah, maybe I'll just save the truck. I mean, just curious. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I can also do this. Yeah, I mean, save the trouble of me getting anything wrong. Size of area is non-integer type double. Looks like I can do this. 5 zeros it is then. 1, 2, 3, 4, 5. Okay. No matching function to call for min. This is the first min, isn't it? Yeah, let's take a look at the main function in C++. I might be missing something. Okay, let's just copy and paste this line here. Okay, and then maybe what I'll do is I'll just delete outer minimum. See whether this thing works. Minimum. Yeah, maybe I don't have algorithm. I had algorithm already, so okay, let's just see whether this gets printed out. Nope, there's an error. Okay, let's say if I take away these apps. Still giving me an error. Is it because I do a long and then here's an integer? This should be long also. Maybe if I change this to long, this would work. Now it works. Okay, so now we go back to our original one. Can this work? Okay, it works. So this is a case because I use integer instead of long. Maybe I should just use long for everything. Saves the trouble of debugging when it not incompatible ints. Okay, I forgot to print out the total, so I cannot really compare whether my answer is correct. So it's 2 and 8. Okay, I don't think this will pass, but let's just try to submit and see whether it passes. Okay, because I believe that the 10 to the power of 9 case would fail. But who knows? Let's just try solving this problem. Sample failed. Compile error. Oh, okay, because of this line here. Unless they don't have this long max. Maybe I just quite 10 E14 instead. Maybe the long max is not defined in their compiler. And we see what happens. Yeah, I don't think it would solve the test case 2 and 3 with this uh, code. Okay, so probably we need to do some sort of averaging. So we need to take two averages. One average is the average when we already do the loop around. Yeah, I'm really thinking of how to do the averaging. So we need to take into account two different averages. So we have a long total one and total two. So C in, maybe we have another variable called v. C into this will I equals to v. Okay, total one plus equals to v. So over here we need to scale this to, so we scale this to make all values shift by n over 2 so that we can do combination log at the 1 to n position. Yeah, so in order to do that, we just v plus n percent n. Yeah, this might work because we already shifted this. So when we then calculate the, so here we don't need this for loop. If you were to do this, just need to do for averaging without shifting. So yeah, the total one divided by n. Actually, what I should do is I should take this and then I round it. Or what I can do is I can take the integer and I yeah, so we can do this. So this is the case for without shifting. We do a round. We do a round of this target. So all this will be target. Yeah. So this just eliminates the double loop. Yeah. So this is like that. So I only do a loop of j. So then my target for this would be total 2 divided by n. Okay, and since I actually did this shift averaging by shifting, I still have 2 plus n divided by 2 and do a modulo by n again. Just then I shift it back, shift back the target, the default orientation. Yeah, I think these two should suffice to solve this problem. Invalid operands to binary expression. I did the target twice. Okay, so has it give a time limit exceeded? Yes, time limit exceeded. Yeah, so it already failed on the second test case. Yeah, so basically, what do you call this? Invalid operands to binary expression. 1.0 times total 2 divided by n plus n divided by 2 modulo n. Hmm. Unless after I do the round operation, C++ round operator. I think it gives me back a float. So I maybe need to map it back to long long. So let's try doing this and map it back to long long here. And typecast it to long long as well over here. Okay, so now it works. Now let's just put in this thing. 2.8. Okay, so this looks good to go. So what I did was I basically considered the case where I just average the case without shifting the values, and I average the case where I shifted the values. This is to cater for the case where there's a jump between like 1 and n. So I take the average, which is probably the least number of moves to shift it. Okay, so let's just see whether this works. If this doesn't work, then I don't know how to solve this question. I will have to check analysis in order to find out. Yeah, this is a difficult problem in the sense that it requires quite a bit of thinking. But luckily, I think there was one Clash of Code problem based on this, on the logs one, and hence I had some practice on this already. Okay, so there's a wrong answer here. Yeah, what could have happened is that maybe there's an issue with this shifting. Okay, let's just see what my target is. I'm gonna put in this 2 and 3. Okay, valid targets 2, 7. So actually going by average may not be the right way to do it. Just wondering whether is it it's a long value, and then maybe what I do is I'll just just take this divide by n. Yeah, so always goes downwards. I mean, I can do like three values in that range, I guess, the average, just to play safe. So it's 1, 3. Let's try solving this again. Okay, 2, yeah, 2, 5, 5. 1, 4, 4, 4, 4. And the average is 3. Okay, so that's the issue here. 4, 4, 4, 4, 4. Yeah, I mean, what I did initially was take away the long, but let's say if I let's say I put it back. Okay, so this this thing, even after I round it, okay, lost a bit of precision. So say if I do the case 2, so there's some precision loss here. So actually, yeah, I don't need this. Let's do this. Let's do this. Let's do this. Okay, and then what I'll do is, so we just do some wrapping of the target, like plus minus 1. Okay, so this one change back to I again. Okay, and of course, if I is smaller than, okay, so over here, we do need to cater for the fact that this target minus 1 might be already like looped on round already. Like it could be target is 1, and then when you do a minus 1, it will become it will loop around to the other side. So if I do a modulo in C, it could be it could be a negative number. So I cannot just do this straight away. Okay, what I need to do is, if this is the current index I percent n. Okay, so it's like, okay, so current target equals to I. Okay, current target plus equals to n. If I greater than n, then current target minus equals to n. It's called cater for boundary cases. So it's still going to be I after all over here, and I'll just take this here, copy this. Then I do have another target here that I want to do. I do it over here. I is target minus 1, target plus 1. So I divide like that, and then I do plus minus 1. Okay. So I didn't define my current target, right? So let's define it here. Undeclared identifier I. Yeah, I forgot to declare a long I. Okay, okay, great. We can check out this. Okay, let's just hope that this solves the problem. All right. I mean, if this fails, then I will see the answer because I think my method may not be able to solve it. Actually, why not? Let's just take a look at the analysis while it's loading. Yeah, y minus x and minus y. Yeah, so it's like that. Okay, a major operation by bringing all the wheels to one of the initial values of the given wheels. Oh, it's not the average, it's the initial value of the wheels. Okay, equals 1 as the first wheel. Okay, alright, so we try for number of wheels. Consider number of moves for all wheels. Consider any wheel we can add the two inequalities. P where we can get some this. Oh, we need to do all. Oh wow, we need to do for all the particular wheels. You cannot just take the average. Yeah, because there's a case where it might look. So it turns out that average will get me a wrong answer anyway. So I cannot do the averaging method. I have to do this method here, which is slightly more complicated. But the idea is just to find out number of moves for all wheels efficiently. Number of moves required for all wheels to reach a particular value efficiently. So yeah, get some gives the value. Yeah, the index is one I and j. But this is a difficult problem. Yeah, wow, more difficult than I expected. Okay, anyway, I got to go already. But yeah, that was interesting, this problem. I'll take a look at this again next time. And yeah, do join me again next Friday if you're interested for more Kickstart problems. I'll be going through probably one of the earlier rounds again. And yep, so, tomorrow will be Clash of Code. So yeah, catch you around next time. Okay, see ya.